let's get some problems done. Just maybe someone keep an eye on the time so that like a little before 1, I make sure I stop by, okay? So if I don't pay attention, you guys let me know. Okay, so let's remind ourselves, guys, back to me. Let's remind ourselves how to read the limit notation. So let me just give you an example of example A here. The limit of the function p of x as x approaches negative infinity. So that's going to the left. Our y values are going up towards positive infinity. The limit of the function as x approaches positive infinity, which is to the right, is also going up. So that's same in behavior. That's when you have an even number, so it's not that one. Let's skip to the proper answer. As we go to the left, we're going up. As we're going to the right, we're going down. So that's an up, down. Okay? So reading our limit notation. Okay? This is a huge, important concept. I created a module in Canvas that you guys probably saw yesterday, and it's at the top, and it's AP, pre-calc, exam, resources, and information, or whatever. And I'm dumping stuff in there every day. Tons and tons of great information. One of the big concepts that we talked about at the beginning of the year that was confusing, and I remember having good conversations in this class in particular about increasing, decreasing rates and all that stuff. And I put a one-pager in there that really gives you a visual and in words all the differences that you could see with the increasing and decreasing of a function versus increasing and decreasing rates, okay? So what we're looking for is the interval. Remember, interval is what part of the x-axis is the water increasing, so is the graph going up, and decreasing rate. Anytime we talk about increasing or decreasing rate, we're talking about concavity, and decreasing is down, so it's concave down. So we want to find what part of the x-axis is our function going up and also concave down. And I'm hoping you guys saw that it was from here to here. So we're increasing concave down. If we continued on, this would be decreasing, but still concave down, okay? But 0 to 9 is the only place the graph is increasing and we're also concave down. So that's a really big concept. We've seen that over and over again in this class. Okay. Number 3, I struggled with this problem at first. I couldn't figure out what it was really asking, so I always like to share with you when I get confused about something too, because maybe it helps you. But anyway, let f of x, be a function with this domain, so these x values. We don't know what the f function is, we just are given what x values apply to it. Function g is here. So g of x is taking our f of x function, you can see it kind of embedded in there, and doing stuff to it. And we know this language. To some people, this might be really confusing looking at that, but I feel like you guys are good at knowing what the language of algebra is and knowing that where these numbers are and what the symbols are tell you really specific things that are being done to the function. For example, the 4 after the equal sign is a vertical stretch by 4, right? It stretches your graph by 4. Inside the parentheses, inside these brackets, that's everything that's being done to your x values, your domain. There's a hint right there. The 2 is a dilation or shrink by a factor of 1/2. You remember you have to flip it in there, and it moves all your points left 3. That's also affecting your x values. And then outside of the brackets all the way to the right, that's your vertical up or down. So that would be down 1. So the 4 in the front and the -1 in the back, that's going to affect your y values, stretching it vertically and moving it up or down. It's the stuff in the parentheses that will affect the domain. So all we have to do is drop this domain stuff in the middle of the other guy's domain and then solve for x. And that'll give us our new domain. So this is the stuff that will change the -6 to 12. So I'm going to divide everybody by 2. And then subtract 3. And so that's written one-way interval notation, so as an inequality interval notation, same idea. Okay? So you only are going to apply the stuff that has to do with the x's. Okay? Here we have a table that gives values for the function h at selected values of x. So understand what these charts are. We've seen all types of input-output charts, XY charts, R theta charts. I mean, how many have we seen? We know this is algebraic, x and y. Inputs are x's, outputs are h of x or y. And what is the average rate of change? There's that term that we have seen so many times throughout this year. I mean, starting with the average rate of change known as slope of a line, right? Finding the slope between 2 points. Finding the AROC on a curve, which is just between 2 points. It's all the same formula. It's a change in the output over the change in the input. We don't know what this is, but we are given some ordered pairs. That's all this is. And what we want to know is what is the rate of change from x is -1, that's this ordered pair, to x is 7, which is this ordered pair. So this is just your change in y's over your change in x's. So 5 minus -4, right, these are my y's, over 7 minus -1. And remember, this is the non-calculator portion of your test. You have to be able to work with negatives without a calculator, okay? 5 minus a negative, they become plus, 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 9 eighths, okay? So, slope, find the slope. Did we all get that one right? Pretty much, yeah. Number 5 is the worst problem in the world. It's probably my least favorite problem I taught all year, to be quite honest. These problems are work. And so as we go through all the review stuff that we're going to do in this class, one of the things I want to always point out to you is some do's and don'ts on the AP exam, like survival skills. One of these things is, you're timed. You have a very restricted amount of time. And I forgot the math of it. I'll know another day, but I think it's like 3 minutes or 3.5 minutes per question. Now, some questions won't take a full 3 minutes, so you'll have extra time for others, but on average, it's something like that, okay? This question takes more than that for most of us, because it's got a lot going on. So and remember, guys, all the things I've taught you this year, all the things we've done, I mean, we've done so much work. Just look at all your binders, okay? The bottom line, though, is that we're going to have 40 multiple choice questions. That's it, 40. What 40 concepts are they going to question us on? We don't know. So we just keep practicing lots of different problems, so we have lots of encounters, and hopefully something looks familiar to us on the AP exam, and we're good. If they give us this problem, this is my advice, unless you're super confident, I would skip it and save it for the end. Make a quick guess. And we'll talk about guessing another time, but make a quick guess if you want to, but note somewhere to go back and do that with extra time, okay? I'm going to show you how to really cut down on this time on this problem, or to at least get to a 50-50, but I'm going to finish the whole problem. So let's talk about it. I hated teaching these to you, by the way. All right, so we have f of x, we have g of x, and we have h of x, which is f of x divided by g of x. And the first thing we have to do is factor. So we have to factor the numerator, factor the denominator. So let's start with that. So in my numerator, I'm just going to find some workspace. I notice I have a GCF of x, so I'm going to factor that out. And then that would be a chart problem of the two numbers that multiply to get -8, add to get 2, +4, -2. Okay? So my numerator would be x, x plus 4, x minus 2. Okay? My denominator has no GCF. I'm going to go right into the chart. The two numbers that multiply to get 10, add to get -7, are -2 and -5. Okay? So depending how good you are at factoring, that could take a while. All right? The next thing you would have to do is find all your critical values. It's been a long time since we talked about that. Critical values are the zeros of all your factors. Let me say that again. The zeros of your factors. So these are factors, and if you set each of them equal to 0, you get the 0, or the solution of that factor. That's where stuff happens on a graph.